Hello, my name is Rob Garner. I am a computer programming instructor, and today I'm going to demonstrate how to use pointers in C++. I've already created a project. It's a C++ project called Pointer Demo, and I've established the normal things that we put into a C++ program. I'm including IOStream using the standard namespace. I've got my main method and some comments. And what we're going to start off with is just a simple variable declaration. So I'm going to declare a variable called number1, and I'm going to assign it the value 6. Next, so we can see what is actually in that number, I will display it with a cout command. And also what I'm going to display is the address of that variable. And to do that, I'm going to use the address operator, this AND symbol. And the way you can read this is cout the address of number1. So whenever you see this symbol here, think of it as the address of. I'm going to compile it and run it. And we can see that we display the value that's stored in number1. So that when you see a variable, think of it as the value stored in number1. And then when you see this AND symbol in front of the variable name, think of it as the address of that variable, in which case we see 0048FE88. This number is in fact a hexadecimal number. And the reason we use hexadecimal is that it is very easy to convert binary numbers into hexadecimal. And if we were to display this number as binary, it'd be a very long number. But by converting to hexadecimal, it's a rather efficient way of displaying a memory location. So in this case, 0048FE88 is the address where the number 6 is currently being stored. Now suppose we want to store the location in itself into a variable. So what we're going to do is declare a pointer, and we're going to assign the address of the variable called number1, and we're going to place that in that variable. So in order to do that, we will use the double keyword, which says that we're going to be declaring a variable of type double, but we're going to add the asterisk, which says this is a pointer to a double, not actually a double itself. So the asterisk is very significant. And we're going to call this pointer num. Next, we're going to take pointer num and we're going to assign it the address of number1. And I used the wrong symbol. I need an AND, not a $sign. So what we're doing here is we've declared a pointer to a double. Think of that asterisk as pointer to a double. Pointer num is a variable that is a pointer to a double, and we don't want to put the actual number 1 into that pointer to a number. What we want to put into that pointer number is the address of number 1. So pointer num is a pointer to a double, and it contains now the address of the variable number 1. And of course we want to see what this looks like, so we're going to use our cout command again, and we'll display ptr num and what this will display is the value stored in ptr num, which we expect to be this address of number 1. Again, I'll compile and run it. And what we see is number 1, that's what's, it has the value 6, which is what's stored in the variable called number 1. The address of number 1 is 00E9F760 this time. Why is it different? Well, because every time this program runs, it stores its variables in a new location. And then we see that ptr num, which is assigned to the value from the address of number 1, is in fact that same address. So now we have a variable which is holding the address of this other variable. And so that's why we call it a pointer, because in reality the ptr num is pointing to number 1. So the next question is, why do we need to have these things called pointers that points to numbers? Well, there's a lot of reasons, but one of them is what if we wanted to have a function that returns more than one value? Normally functions return one value. So let's make a function that returns one value, just to remind ourselves how functions work. So I could declare a math function, and let's say this math function is going to do something very simple. It's just going to add 2 values and return it. So I can do that with return num1 plus num2. So if I pass in 2 values, it's going to return the sum of those 2 values. Of course, if we have a function, we need to declare its function prototype at the top. And from within our program, we're going to call it. So we have a math function. It takes 2 parameters, num1 and num2, both of them are doubles. It adds them together and returns it as a double, and that will come out of this math function call here. We place in summation, and we'll display that. And we can see, well, we have a problem. And we need to initialize this value. So we'll initialize it to 4 and to 6 so that we get the value 10 returned. Let's try that again. So I'll compile it, and this time it works. So we can see that it set value 4 into number 1, value 6 into number 2, summation was initialized to 0, but then was assigned the value of the result from the math function that we created. We passed in number 1 and 2, which is 4 and 6. 4 and 6 were added together, returned back to summation, and that is now displayed as 10. So that's a typical function. Nothing new there from other times we've worked with functions. But let's say we want to, in addition to summation, we would like to get the subtraction of those two numbers. And we would like to do all with one function. So, well, the return only returns one thing, so that's not a good way to get two things back. So what if we instead said, I'll just return it through the parameters. So I'll added two additional parameters. I won't use the return. And I'll just say sum is equal to num1 and num2, and sub is equal to num1 minus num2. Make sure whenever you change your function that you change your function prototype. And over here, we're just going to say, since it's void, we're not going to assign it a value. When we call it, we're just going to pass in summation and subtraction. So what we're hoping to have happen here is we have these parameters. We'll just assign them the value of num1 plus num2, num1 minus num2 in sum and subtraction, and maybe they'll come back through these two variables and be placed in summation and subtraction, and we'll be able to see them. And let's run that. So I'll compile it. And, well, it's returning 0, the values I assigned. But why didn't it take in summation and subtraction and update it with the values I placed here? It did these calculations, but it didn't pass them back through the parameter list back to summation and subtraction. And as a result, summation and subtraction still equals 0. So this doesn't work. We can't use our parameter list in this way in order to return more than one value from a method. But there is another way if we use pointers. So we're going to make a few changes. First of all, we're going to change our function so that rather than a double, we're going to make the last two parameters be pointers to a double. And if we assign these as pointers to a double, we don't want to actually place the sum of num1 and num2 into the pointer sum, because this is now a pointer. And in fact, maybe it might make more sense if we rename it to pointer sum and pointer sub. What we want is we're going to dereference this pointer and say the memory location pointed to by pointer sum will now be given the value num1 and num2, and the memory location pointed to by ptr sub will now equal num1 minus num2. So now, rather than actually putting the num1 plus num2 into the parameter here, what we're doing is we're using the parameter that's passed in as a pointer so that we know where we want to put this summation. And with the subtraction point, with a ptr sub, we're doing the same thing. We're placing the subtraction of num1 and num2 in the memory location pointed to by ptr sub. So think of this asterisk in front of a pointer as the memory location pointed to by that pointer. And up here, when we say double and asterisk, we're saying that's a pointer to a double, and that's a pointer sub is a pointer to a double. Again, we changed our prototype, so we need to go up and make sure that our function prototype at the top is the same. And now we can't pass in the variables sum and subtraction. Instead, what we're going to use is our AND operator. It says the address of summation and the address of subtraction. So we're not passing in the contents of summation and subtraction. What we're passing in is the address to those two memory locations. And so the address to those two memory locations will be passed into as parameters into our function, and then we will dereference those pointers in order to put the addition of the two numbers into the memory location pointed to by pointer sum, and the subtraction into the memory location pointed to by PTR sub, which will be these actual two variables. And then when we print them, we should get better results. And in fact, we do. We can see that four and 6 were passed in as number 1 and number 2. The addresses of summation and subtraction were passed in as pointers, as address locations. And then the function used those as pointers and placed the results. So 4 plus 6 is equal to 10. That makes sense. And 4 minus 6 is minus 2, and that makes sense. And so this actually is a way we can return multiple values by using pointers. This completes my demonstration of pointers. Thank you very much.